So today's LeetCode problem is invert binary tree. So given the root of a binary tree, we have to invert the tree and return its root. First, we'll just be given a root. So we see that our input will be 4271369, and then our output will be 4729631. So what really happens over here is there's 4 in the same position, 2 and 7 are swapped, and here 1 and 3 are 1369. So they're exactly the mirror image of 1369 and 2 and 7. The exact mirror image of this tree is being given over here. So what happens is 9 goes to the other extreme, 1 comes to the other extreme. Similarly, 6 and 3 are also swapped, and since the entire binary tree is inverted like a mirror image. So that's what is happening here. And what method we are going to use for this? First, we will just okay, there's the class solution already given, and tree node star invert tree of tree node star root. So we are just going to get the root of a binary tree. So our root will be given, and now let's just see our approach. Let's just take our binary tree to be 4271369, and here we see that it's just a mirror image of this. So this is our original binary tree, and this is our inverted binary tree, and we see that that's 427 here and 1369, and hence it's inverted. It's actually the same example. So what we're going to do here is we're going to use recursion over here, and 4 will be our root. We just consider 4 as our root, and these are the leaves. These are internal leaves, and this is internal nodes, and this is the leaf nodes. And by using recursion, we're just going to use pointers, a left pointer and a right pointer. A left pointer will be pointing to 2, and right pointer will be pointing to 7. So first we will start by making a left call, and then we will process the left subtree. As we keep on processing the left subtree, we'll go until the end, and once we reach the leaf node, we will just backtrack. We'll just go back, and then we will just from that node we can just process the right side as well. And after processing the right side as well, then we will just go back to our 4, right? For example, we start from our root node, then we are going to we're going to make a left call, and we go to 2. Then again we're going to make a left call, and then we go to 1. We will go to 1, and from 1 we will just we find that it's a leaf node, and hence we'll go back to 2, and then finally we'll go back to 4, and we won't go back to 4 from here. From 2 we will just go back to 3 again, and because we didn't process the right side, and from 3 we will go back to 2 again, and then finally we'll go back to 4. And now we have processed the left subtree. Then we will make a right call, and we will go to 7. From 7 we will go to we will process our nodes, that is 6 and 9, and hence after processing we will just go back to 4 as well. So we will make a left call, process left subtree, then we'll process the right side. Then after processing the left subtree alone, that is 4, 2, and 3, what we're going to do is, after we go to, it's like post order traversal. After we reach 2, we will just process 2. Okay. So what are the leaf nodes of 2? That's 1 and 3. So we will just swap 3 and 1, just like we are going to swap two numbers. For that, we will just use a temporary variable called temp. And hence, we will, after swapping it, we will just go to 2, and finally we'll go to 4, and then from 4 we'll go to 7, and then from 7 we'll go to 6 and 9. So then we will swap these two, 6 and 9, and we'll go to 7, and we'll go to 4 back again. Next we're going to process the node 4. Node 4 contains two leaves, two nodes, internal nodes, that is 2 and 7. Then we will swap 2 and 7 as well, and 7 using the temporary variable, and finally root node remains at the root node. So what we're going to do is we're actually playing with the pointers. We will just swap the pointers. We will make the left child as a right and the right child as a left, and t is storing the current left. So in our program, t will store the current left. Basically, it will store the current left pointer, and thus pointer will change, and we will swap it. We need to make a call to the right subtree after the left, and finally we have to go to the node 4, and then after we process the node 4, we will swap all our leaves, and after swapping node 4's children, the 4 remains in the same place. So we will get the, basically what we're doing in the problem is that we're getting the root. We are calling swap function. There's a swap function written, and then we will return a root as well. So basically, if we return a root, that means our entire tree gets returned, and we will make a left call and right call, and finally we will do some processing. And if the current node is null, initially we are going to check if the current node is null. If it is null, then we will just return it. Complexity is order of n. So let's just try to code this. As I said, we have to first write a function. I mean, public. We will just call that swap function. We will get our root over here, and swap function we will just write it later. We will return root in our public. Then after returning root, this basically does is it creates a mirror image of our tree. Then then we are just going to make a function outside, I mean inside our class solution. It'll be a void function. But basically what we want to do over here is we are just going to swap it. We're going to process the nodes and swap it. So it's not going to return anything. Just swapping is what happens over here. Then okay, we're going to get a current and then a current node. So if our current node, that is our root node, is null. Okay, so it's not equal to current. If it is null, we'll just return it. Then as I said, we have to um we have to we have to call our swap function, and we will just point it to left. We will make our left calls and we will make our right calls. This is the left call, and then our right call is this is our right call. Now we are going to swap our child pointers. That is the pointers pointing to the child, and here how are we going to swap our child pointers is we have named it a tree node, right? So we will just use our tree node. We are going to create a temporary variable over here. Then that temporary variable we will just equate it to whatever we are going to equate it to our left. Then our current left we are going to equate it to our current right. Then our current right will be equated to our temporary variable. That way we have swapped it, and yes, we have swapped it. We have swapped the child pointers. So let's just see if this works. Yes, so we have inputted our our tree 427 1369 and we have gotten our output as well. So in this case, we have swapped the child pointers, and this is just for calling, making the left and right calls. Then this is for getting the root and swapping it, and then we are returning the root. For example, if our root is an empty array, that means we will just output our output will just return the same thing. So this condition, this block of code is just for this case, and there are certain constraints also given. So this the order of time complexity for this will be order of n, because the worst case would be that a node is processed 3 times. Thank you.